Bismillahirrahmanirrahim. Bedari, today we are going to continue with our topic, the series circuit. Series circuit is said to be potential divider circuit. And why and how? In, in series, the current is same through all, but voltage is divided. And how the voltage is divided? That is divided according to the value of resistance. If the different resistors are there in a series circuit, the larger resistance will receive larger voltage and opposite. So the potential difference is divided according to the voltage will be directly proportional to the resistance of every conductor or appliance, right? So larger resistor will receive larger voltage. They are directly both. This is only for series circuit. Keep it in mind. And that is why series circuit is said to be potential divider. So today we are going to discuss mainly the potential divider aspect. And the voltage is divided according to the value of the resistance. And we practice these formulas if we are having three resistors, R1, R2, R3, and their combined resistance, equivalent resistance, RE, is equal to the sum of these resistors. Then the voltage around the first resistor will be R1 over RE multiplied by the total voltage by the source battery. Similarly, the voltage around the second resistor will be R2 divided by RE times the total voltage. Similar for the third device appliance. So now, uh, yeah, last lesson we discussed how the voltage is divided, and the same formula we practice actually. These formula, they are actually one same formula, and that is not a very any big formula. Actually, this is a simple ratio proportion technique which we use to find the share of the profit by the three investing investment for different persons. Let's go on with this topic. Here is the question. It's from the past papers. Numbers can be different. You can see here is we are having two resistors in series, and then another two resistors in series, and both of these series combination are in parallel to each other, right? Here, for our convenience, we have mentioned this point as a terminal to be A, and this is terminal B, and this is terminal C and D, points C and D, right? So the question is, if the potential difference across A and B, or potential difference between A and B point is 20 volt, what will be the potential difference between point C and D if these two resistors both are 20 ohm and this one is 10 ohm and this one is 40 ohm? We have to find potential difference between C and D. So to do that, first we have to find the potential at point C and D, then we will find their difference. How would we do this? So we are having two paths, one this upper one in series, the one path is this one, the other path is this one, right? Clear? So when we see the upper path, this one, here we are having two equal resistors, and whole this path is receiving 20 volt. So when we say now the potential difference between A and B is 20, you can take any of the points A or B as 0 and the other as 20. So the difference between 20 and 0 is 20 volt, right? So it's not necessarily you take A to be 0, you can take this to be 20 and this can be 0 then. Result will be same because voltage and current, they are scalar quantities. So either way they will give you the same. So what do? Here we take the voltage to be 0 and 20 at B. So the potential difference between them is 20 volt as given. Clear? Now, what happens? So when the resistors are equal, then voltage will be equally divided now. So 20 will be divided 10 volt, 10 volt. It means each will consume 10 volt, each appliance. So what does that mean? Means if we start moving from 20 volt, let me tell you, if we say the voltage here is 20, then both these points are connected with the same. It means both these terminals will be having 20 volt potential. And if this consumes 10 volt, means after consuming 10 volt out of 20, we will be left with 10 volt at C point, right? 10 volt will be consumed here now out of 20, so 10 will be left. Then this again consume 10 volt out of 10 and 0 will be left. So it means at this point, all these points, the voltage will be 0. So mathematically, we reach from 0 to 10 as 10 volt plus 10, 20 volt are consumed out of this 20 and we get 0 result, right? Clear? Similarly, how many voltages are consumed by this 40 and 10? So we can, they are series, we can use formula. Their combined resistance 10 and 40 is 50. If we want to find the voltage consumed by 40, then 40 will be divided by the 50 combined resistance and multiply by the total voltage. So it will be 16. Similarly, we apply the formula, it will consume 4 volt. You can see the working here, right? Clear? So when we say
Yes,
that it
sir.
consumes 16 volt, it means we will start from the 20 volt. If it consumes 16 volt, then how many voltage will be left? 4. And then this consumes 44 volt out of this 4. And how many will be left? 0. So one thing you have to see, very balanced. In both paths, we start from 20 and reach to 0 voltage. Similarly, we start from 20, this 20, and reach to 0. So the circuit is balanced, right? Mathematically, we can say how the difference is potential. Here we were having 20, the 4 was 16 was consumed here, 4 was consumed, so total 20 is consumed and we are left with 0, right? Okay, now coming to this was these were the logics I was discussing. Actually, we had to find the potential difference between C and D. So our first mission was to find what is the potential at C, that is 10 volt, and at D it is 4 volt. So what will be their difference? Means difference between the potential of C and D. 10 minus 4 will give you 6 volt. So this is the answer. Is it clear?
Yes, sir.
Right, beta ji? Hassan, fine. Should we move on?
Yes, sir.
Okay. Acha beta ji, next question is again a past paper question, a very important one. Beta, consider we were having a similar sort of combination, right? This was in this laid in this way horizontally, and the same is now drawn vertically. The combination is same. So when you draw in different direction, you don't need to be panic or feel any difference. They are exactly the same circuits. But now here we were having, the scenario is we were having two resistors in series here, and one of that is 10 ohm and the other is 20. Similarly, on the other hand, the two resistors is 12 and 24. And the best thing, the most important, if there is a voltmeter or ammeter connected here, both will be giving zero reading, null. Beta, it is one of the important questions which are called as null methods. Why would it give zero reading? If we apply the same method to find the voltage, like the combined resistance of 12 and 24 is 36. And if we have to find the potential difference, and the potential difference here between these 2 points is 12. The potential difference between these two terminals is 12. So if we want to find the potential difference by 12 ohm, we will divide 12 ohm by their combined resistance of 12 and 24, 36, and multiply by the voltage 12. So we get the answer to be 4 volt. So it consumes 4 volt. And similarly, if we apply the same technique formula, we get 8 volt here. So from out of 10, 12 volt, it will consume 8 and 4 will be left, and it consumes 4 and then 0 will be left. So at this point, the potential is 4. The same formula or wave we applied here, we apply here, and this, we again find the voltage consumed here are 8 and 4 volts. Means the voltage here is 4 and 4. So the potential difference between them will be, the difference between 4 and 4 will be 0. And where voltage is 0, the current will also be 0. If there would have been an ammeter here, then that would have given the 0 reading as well. Now, there is one thing I would like to share. The main point is this. Whenever you see two resistors R1, R2 in series, in parallel with the series combination of R3 and R4, and the voltmeter and ammeter between them is giving 0, null reading. So beta, the ratio of R1 and R2 then will be equal to ratio of R3 and R4. You have to keep this in mind. And why ratio? Because we said na, the voltage is divided according to the ratio of resistance, value of resistance. The voltage is directly proportional, had direct ratio, constant ratio with resistance. So beta, as voltage is divided according to the value of resistance. So similarly, you can say, isn't this 24 the double of 12? And isn't this 20 the double of 10? Their ratios are same. 12 divided by 24 gives the same answer, the 10 divided by 20. So beta, I'm going to make it shorter. You have to keep it in mind. Whenever the two series combination of two resistors are connected in parallel with each other, and the voltmeter or ammeter in between, in the middle of connecting the middle of both the combination, if it's giving null or 0 reading, then R1 over R2, the ratio of these parallel will be equal to each other. And how this will be asked? In past paper question, you will be given the value of this resistance, this, and this will be asked, the R4. So you will put the values of the other thing, and the next you can calculate by simple using this ratio. Can you keep it in mind? Clear? Right?
Yes, sir.
Yes, sir.
Okay. Okay, now let us move on. Vedadi, we said this is the concept now we are going to discuss. You have discussed in O level, but it's still very important. As we saying that series circuit is a potential divider circuit. Let's say we are having two resistors, RT thermistor. This is the symbol of thermistor. And a fixed resistor R. They are in series and they are connected with a source of which is providing the total voltage, you can say V. They are in series. So voltage is divided across both of them. So let's say to find their voltage, we connect two voltmeter, the V1 across this one and V2 across this. So let's say the thermistor is heat sensitive resistor which changes with temperature. So at normal temperature, or you can say room temperature, R and RT are equal. So when the resistors are equal, their voltages will also be equal. And how much voltage will be equal? Because only two objects are connected here now, and when will be divided between these two, the total voltage V will be divided, then each will be having half of the voltage, right? But if the temperature is not normal, not at room temperature, it will either be at higher temperature or will either be at lower temperature. So what happens? The temperature only affects thermistor. That changes with the heat. So, and it changes inversely, right? I guess we discussed. So when temperature increases, the thermistor will decrease. When temperature will decrease, the thermistor will increase. So initially, when both were having fixed resistor and thermistor were having equal resistance and they were having equal reading of voltage as well. But if the RT will decrease, what happens? In series, the voltage is inversely proportional. In series, the voltage is directly proportional to the resistance. So the resistance which decreases, its voltmeter reading will also decrease. And what happens? They were equal, initially they were equal to each other. So when this one decreases, now this is a fixed. It was fixed. It did not change. So when this decreases, now this becomes larger. So its reading also increases, has increased, right? For example, when both were having a total voltage was 12 and this was they were having 6 each. And if this decreases to 3, then it will increase by 3 and it will change to 9. But the total voltage will always be equal to the total voltage supplied, right? Clear? And similarly, if there will be a drop in temperature, then thermistor inverse relation will increase, and then RT increases. Then, as we know, the voltage across the resistor is directly proportional to its resistance. When it increases RT, the reading of RT will V1 will increase, and automatically when it has increased, now this is the smaller resistance. R will be smaller as compared to RT now, so its voltage will be lesser. Again, we are practicing the same relation, and same happens when there is an LDR uh, in place of the thermistor. The difference is LDR thermistor changes with temperature and LDR changes with the light. So larger the, if the light will increase, the it again has the inverse relation with light, right? Like thermistor have inverse relation with temperature, LDR has inverse relation with light. So when intensity or strength of light increases, LDR will decrease. The resistance of LDR will decrease. So when this resistance decreases, so its reading, voltmeter reading will decrease. The other is now larger and its reading will increase. It's just like if one pizza is ordered for two persons. So most probably and commonly they each share half of pizza, half each, right? But if one person uh, doesn't feel much hungry and eats lesser than half, it means for other person more than half will be left. More will be left for the other. And if first person is more hungry and eats more than half, it means less will be left for others. So similarly, when we say the voltage is divided between these two voltmeters readings, actually voltage divided between these two resistors. So if one will receive lesser voltage, the other will have more of that because the total will stay the same. And if one receives larger, the other will receive lesser, but the total will remain the same. So these were the the concept of potential divider in series. Any question, beta?